Good evening, all of you. Am I audible? Audio, video clear? Please mention. Just check. So today will be the last lecture on the number system unit. Please mention whether the audio video is clear. So today we are discussing miscellaneous number system problems or miscellaneous number system concepts also. The concepts that we haven't discussed in the previous classes, that is what we are discussing. So please invite all of your friends to be part of this lecture. Yeah, audio. Checked in my phone. Okay, so invite all of your friends who are preparing for the upcoming UPSC exam and for other exams, CSIR NET, GATE and other exams also. This course will be very useful. So for the new people, my name is Christy Varghese. More about me you can see here, and these are the books I have written, and these are the courses I offer in the mobile application classes. The flashcards that I am showing in the class, that is available as an ebook in these classes mobile application. You can check the description of the video to get more information. And for CSIR NET exam, GATE exam, paid courses are available in the mobile application classes. And also, these are the free resources you can be part of: the Telegram channel, WhatsApp group, and mobile application classes, and the website Christy. Okay. The links of all these resources are there in the description of the video, or these QR codes can be scanned. And check out this YouTube channel where you can find playlist of different exams. And for UPSC exam, this is separate playlist. For CSIR NET, GATE, Vedic Maths, you can see different playlist in this channel. So you all are welcome to be part of this community, and subscribe the channel, hit the bell icon so that you will get updates of all our upcoming. Okay, so today's topic is miscellaneous number system problems or miscellaneous number system concepts. We discussed about types of number, digits and place value, arithmetic operation, divisibility, LCM, HCF, remainder theorem, surds and exponents, etc. But there are some concepts which we haven't discussed in number system, and there are some questions where multiple chapters which we discussed, based on that questions can be asked. So we will be covering that also. Is there any lag in the video? I think audio is perfect. Is there any lag in the video? Let me know in the chat. I will cross check once again. Okay, anyway, if it is manageable, let us continue, because it's a 30-minute session, so we don't have more time to spend on it. So we discussed about many ideas in number system. One idea that we haven't discussed is arithmetic progression and geometric progression, because direct question related to arithmetic progression, geometric progression was never asked, but indirectly this concept is needed for other chapters. Data interpretation chapter, series formation chapter. There is a series called arithmetic series, which means a series which satisfies arithmetic progression. There is a series called geometric series or geometric progression. That means, geometric series or geometric sequence. That is a series or sequence which follows geometric progression. So if you know arithmetic geometric progressions only, you can do those questions in those chapters also. Number system is a base chapter for other chapters also. So what you are learning here is needed for other chapters. That is why in this miscellaneous lecture, I am explaining those concepts that you should learn for other chapters to understand it more or do questions from it more comfortably. Okay, so let us start. Arithmetic progression. I hope all of you know what is an arithmetic progression. A progression which have a common difference. Just a minute. Common difference. Common difference, that is called arithmetic progression. For example, the example that I have written here: 1, 4, 7, 10, 13, 16, 19. Look at, just a minute, let me go through this flashcard. Let me just check the video can be file. Okay, do one thing. You try the first question. After that, I will come back to that concept. I'll just check. There is some video lag issue that I am seeing. Others, are you not facing that video lag issue? Or if there is a video lag issue, please let me know. So try this question. This is a miscellaneous question. This has nothing to do with arithmetic progression or geometric progression. I'll come back to arithmetic progression and geometric progression. Please try this question by the meantime. Okay, Shri, I will just check if that can be rectified somehow. I think now it is clear now. Okay, so yeah, just tried something. I hope it is have rectified the issue. Okay, so let's come back to this question. Some of you already got an answer. I will come back to this question. We will complete what we started. Arithmetic progression. What is arithmetic progression? 1, 4, 7, 10, 13, 16, etc. are following an arithmetic progression, because if 1 is the first term, to that 1 you are adding a 3 to get the next term 4. To that 4, I am adding the same 3 again to get the 7. So 1 plus 3, to that you are adding again a 3. To that you are adding again a 3 to get the next 10. To that you are adding again a 3 to get the next 13, and so on. So there is a common difference getting added. That is the idea. Na? So that is arithmetic progression. So the concept or formula that you should learn in arithmetic progression is nth term is a plus n minus 1d. That also you don't have to by heart it. You can understand it here itself. For example, if you want to find the 10th term, to the first term you are adding 3 how many times? 9 times. Na? For the second term you are adding 3 1 time. For the third term you are adding 3 2 times. For the fourth term you are adding 3 4 times. Sorry, 3 times. So for the 10th 3, you will add 3, for the 10th term, you will add 3 10 times, 9 times, 1 time less, because for the first element, you don't have to add any common difference. So for the 10th element, 9 times 3 is added. 9 times 3 is added. Multiplication is repetitive addition. So 9 into 3 you can write. And that is what is generalized here. What is this first term in the sequence? First term, or that is what we call A. What is this 3? Common difference 3. The difference that you are adding, common difference 3. So that is D. What is this 9? 9 is 10 minus 1. That is n minus 1. Which term you have to find? You subtract 1 from that. That is n minus 1 times D. So I hope all of you are clear why A plus n minus 1D formula comes. In school days, we have mugged up a lot of formula, and that is why we feel that aptitude tests are difficult, because we are just trying to repeat, or we are just trying to search for questions where those formula are there, but formula may not be applicable in most of the question. Idea related to formula will be needed in many questions, and moreover, if formula can be applied also, if you know the logic behind the formula, that is much better to do those questions with or without formula. Okay, so anyway, that is the nth term idea. Same way, sum of n terms. For example, if you are finding sum of the first 10 terms here, these are the first 10 terms. Instead of adding 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19 plus 22 plus 25 plus 28, that will take time. Na? Instead of that, there is a formula n by 2 into a plus l, where n is the number of terms. For example, 10th term, if you want to find sum of all those terms, 1 plus 4 plus 7 plus 10 up to 28. One simple formula is first term plus last term into n by 2. First term is 1 here, last term is 28 here. If you know the first term and last term, 1 plus 28 into n by 2. 10 term sum will be 10 by 2 you have to multiply. That is 5 into 29, 145. Now what if you don't know the first term? What you should do then? If you don't know the last term, first term anyway you should know in a sequence. But we are only given 1, 4, 7, etc. The 10th term we are not given in the question, and you are asked to find sum of first term 10 terms. Then what you should do? 10th term is T10 na? Find T10 using this formula and you can substitute it here na? And that is what this formula means. What is L? L is a term that is a plus n minus 1d. That using that you can find the L value na? Because nth term is a plus n minus 1d. Last term is also nth term na? So a plus n minus 1d you can substitute here. A plus n minus 1d will be 2a plus n minus. So this is also another way of representing. This is also a formula you learned in school. This is also a formula you learned in school. The derivation of those two formula is what I have told you. Now, in case those people who are doing last minute revision, and if this derivation is giving you nightmares, what I will suggest you is, for the time's sake, you skip the derivation. At least learn the formula. At least. Learning the logic is the best. But at least learn the formula. That is what I will suggest you. So anyway, I hope it is clear. Similarly, geometric progression means a common number, one common number is multiplied. For example, 2, 6, 18, 54, 162, etc. Yes, IVS, this course is definitely useful for GATE aspirants also, because these topics are there in GATE also, CSIR also, and other tests also. Okay, so anyway, 2, 6, 18, 54, 162, etc. That is a geometric progression, because 2 into 3 is 6. 6 into 3 is 18. That means into 3 into 3. To the 2 you are multiplying 3 2 times. And 54 is 3 times you are multiplying 3. 162 is 4 times you are multiplying 3. So to find the fifth term, you are multiplying 3 4 times. 2 into 3 into 3 into 3 into 3. Repetitive multiplication is exponents. Na? In surds and exponents chapter, we discussed about exponents. So 2 into 3 raised to 4. So in general, nth term is first term into the common ratio, the common number that you are multiplying with, that is called common ratio. Common ratio raised to n minus 1, where n minus 1, because for fifth term you are multiplying 3 4 times only. For 10th term you will multiply 3 9 times, not 10 times. So n minus 1. Like here there was n minus 1. Clear? So these are the basic facts you should know about geometric progression. This chances of this asking is less, but if you want you can learn this formula also. Derivation of that formula is very tedious. In half an hour session I don't want to try that. And for an infinite geometric progression, if terms are infinite, this concept is important. For example, 1, 1 by 3, 1 by 9, etc. up to infinity. When r is less than 1, r means here the common ratio multiplied is 1 by 3. Na? 1 into 1 by 3 is 1 by 3, 1 by 3 into 1 by 3 is 1 by 9, and so on. So that ratio, if it is 1 less than 1, you can apply this formula, a by 1 minus r, only for infinite GP or infinite geometric progression. So 1 by 1 minus 1 by 3, that is simplifying, you will get 3 by 2. Simplification part and all you can do yourself. So AP-GP is one concept that you should know. Now last digit of power, this thing I have told you in the last class. As homework I have given this. If you have gone through it, you may have got an idea. In this channel already I have given 2-3 videos on last digit of power. So I will just summarize this also, because today we are discussing all those other important number system related concepts and questions which we haven't discussed in the previous lectures. The last digit of power, basic idea I will tell you. Detailed idea is very time consuming. I will tell you a few examples to understand. For example, if it is 9 raised or 25 raised to 123 means what? 25 into 25 into 25 into 25 into 123 times. What is the last digit of this? If the question is asking last digit or unit digit, last digit, unit digit, both are same itself. What you should do? For finding last digit, you only have to find the last digits. This 5 into last digit you need to multiply. If instead of 25, if it is 225 also, last digit only you can last digit to get it, you only have to multiply the last digits and obtain the last digit. So 5 into 5, 5 na. That 5 into 5 again 5. So for 5, how many times you multiply again and again with 5, you will get 5 only all the time. That is what this flashcard says. Are you all understanding? Or the cyclicity of unit digit 5 is 1. Cyclicity means how many type of elements can be there in the last digit. How many type of elements are possible for the last digit, that is called cyclicity. For 5, only one possibility. So that is only one possibility. Is that clear? Similarly for 6 also, if it is 6 raised to 123 also, 6 into 6 into 6 into 6, how many times you multiply, you will get 6 only as the last digit. You can try it yourself. For 0 ending numbers also, for example 120 raised to 123, 0 into 0 into 0, any number of times. These are the powers. Raised to 1, raised to 2, raised to 3, raised to 4, raised to 5, etc. All cases it will be 0 only. For 1 also it will always be 1. 1 also it will always be 1. So these 4 numbers you can note down, 0, 1, 5 and 6. Its cyclicity is 1. Cyclicity is 1 means only one possibility. Only one possibility for the last digit. Now the second type is cyclicity 2 type. Cyclicity 2 type means 4 and 6 are those two numbers. 4 ending number raised to any power will be either 4 or 6 only. Look at it. For example, 4 raised to 101 if you want to find. 4 raised to 1 last digit is 4. 4 raised to 2 is 4 into 4, 16. Last digit is 6 now. We are only concerned about last digit. 4 cube, 6 into 4 again 4, 24, 4 again. 4 raised to 4, 4 into 4 again 6. Look at the cycle of 4, 6, 4, 6 repeated. 4 raised to 5 again 4, 4 raised to 6 again 6. So you can discriminate this like this. Even power, it will always be 6. Look at this. Even power. Odd power, it will always be 4. Look at this. 4 for odd power 1 and 3. 6 and for even power 2 and 4. And continuing like that. 101 is odd power. So the answer will be 4. All of you are getting the point. Very briefly I am telling, but I am trying to explain it as much crisp as possible for you to understand. Same with the case of 9 also. 9's power cycle also have only 2 elements, that is cyclicity 2. 9 raised to 1, 9 raised to 1, last digit is 9. We are only discussing about last digit here. 9 raised to 2, 9 into 9, 81, last digit 1. 9 raised to 3, that 81's last digit into 9 na. That is again 9. 9 raised to 4, again 1. Look at the cycle repeated. 9 raised to 5, again 9. Then 9 raised to 6, 1. So odd power 9, even power 6, sorry 1. So that is 9191 is the power cycle. All of you understood? Now the most trickiest type is cyclicity 4 type. Cyclicity 4 type is very time consuming to explain. That is why this example I have listed here is for that. For example, 32 raised to 91, 32 raised to 91 and 2 raised to 91, answer is the same itself, last digit. The 2's power cycle you need to obtain. How? 2 raised to 1, 2, 2 raised to 2, 2 into 2, 4, 2 raised to 3, 4 into 2, 8, 2 raised to 4, 8 into 2, 16, last digit is 6, 2 raised to 5, 6 into 2, again 2. Again 2 means the cycle started repeating. Again 4, again 8, again 6, and this cycle will repeat. That is 4 elements in the power cycle. All of you are getting this? 4 elements in the power cycle, 2, 4, 8, 6. If 4 elements are there in the power cycle, or if the cyclicity is 4, the standard procedure that you can apply is take the power, divide it by 4 and find the remainder. Remainder theorem chapter we discussed about how to find remainders fast now. 91 by 4, remainder is 3. Remainder 3 means third element will be the answer. The logic behind this formula or logic behind this concept is very beautiful and very interesting to learn, but that much time is not there. So sorry for that. That logic part we will skip it for the time's sake. So if the remainder is 3, third element will be the answer. Third element will be the answer. All of you are getting this? Please respond. So in this case, 32 raised to 91's answer will be 8. 8 will be the answer. So basically this is how to find the last digit. All of you clear now? Yesterday I think I have given you a homework question in the end in the certs and exponents chapter. Okay, new students who have joined the series, there is a telegram channel where we post 10 homework questions or 10 practice questions of each topic. I mean, after each of the lecture in this course, the practice questions, 10 questions with the answer key will be posted in the group. So you can check it out for those people who want to practice. So, and those of you are understanding this concept, please do hit the like button. That will help more people to know about this course, because that is how YouTube algorithm works. So please support the initiative by liking the video if you feel it is useful. Okay, so this much is clear, I guess. If we have time towards the end of the class, I will show you one CSAT question where this concept was needed. And this is one concept in CSIR exam. It was asked
I'm having trouble connecting to the internet. It looks like there is an issue with the router and echo device. So try restarting them. Unplug both of them.
Yeah. Sorry for the noise in between. Last digit 2378. Not only for 2378 2378, yeah, last digit 2378, you have to separately find what all will be the power cycle for each of those cases. Yeah, only for 2378. Yeah, what you told is correct. 2378, only for these 4 numbers cyclicity is 4, and only for that 4 numbers you have to follow this procedure I have written here. All those 4 numbers, the procedure is the same itself. Clear? Yes. And this perfect squares identification, this concept, till now in UPSC exam it was not asked, in GATE exam it was not asked, in CSIR exam it was asked. So my CSIR NET aspirant students, you can check out this flashcard to learn this. And as I told, any exam they can introduce new concepts also, which was not asked before at all. In number system, perfect square identification is an important concept, but UPSC fortunately or unfortunately haven't asked. So to tell that it is fortunately UPSC asked this time, try to go through this flashcard if you have time. That is what I will tell to the UPSC aspirants here. The CSIR NET aspirants, definitely you have to check this. This was asked 3 times in your previous papers. Okay, due to lack of time, this part I'm not explaining. Go through this flashcard. For perfect squares, what all can be the unit digit? What all can be the corresponding tens digit? This idea is what is enough to find whether a number is perfect square or not. Okay, basically these are some of the things which we haven't discussed in the previous sessions and which are important. Now we will see a few questions which may or may not be based on the concept we have discussed, because today what I'm trying to do is miscellaneous questions also we are discussing, which may not have been discussed in any of the previous classes. And one question, this question is a very interesting question. This have an application of one of the things we discussed in the previous classes. That is a clue I can give you. So try this question, all of you. Try this question, all of you. This was a 2023 PYQ. All of you try. 2020 PYQ. And those of you are following me for the last few days, following this YouTube series for the last few days, like to hear your sincere comments on this series, whether the series is being useful for you or what all are your feedbacks. Like to hear it. Those of you are watching me live, put your feedbacks in the live chat. Those of you are watching me recorded, try to put your comments, put your feedback in the comment section. That will help me to make the course better also, and that will help me also to be motivated and continue the series with better energy and better content. So I suggest all of you, if possible, try to comment on the video or like or put the comment in the live chat what you felt about the series or what suggestions you have for the series. Okay, some of you got an answer, so I'll start explaining. Just a minute, I'll copy one more question. Searching for a question which was important but was not added in this slide. Okay, done. So most of you got an answer. So this question is connected to test of divisibility also, prime number, classification of numbers also. It's a hybrid question. Multiple chapters in number system is involved here. How many 5-digit prime numbers can be obtained by using all the digits 1, 2, 3, 4, 5 without repetition of digits? What is prime? We already discussed now. A number which is divisible by 1 and that number only. That means no other factor other than 1 and that number. That means 2 or 3 or 4 or 5 or 6 etc. cannot be the factors. So 1, 2, 3, 4, 5 only digits should be used. That can be arranged in whatever permutation combination. But 1, 2, 3, 4, 5 if you are using, for example 1, 2, 3, 4, 5 or rearranging 5, 4, 3, 2, 1, whatever it is, it's sum of digits. If you check it's sum of digits. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. 15 is the sum of digits, means this sum is a multiple of 3, and we discussed that if sum is a multiple, sum of digits is a multiple of 3, the number automatically will be multiple of 3. So the number formed by 1, 2, 3, 4, 5 without repetition of digits will confirm be a multiple of 3. If the number is a multiple of 3, that cannot be a prime number. Number can be a multiple of 3 only for the prime number 3. But this is not the prime number 3. 1, 2, 3, 4, 5 rearrangement, it's a 5-digit number. So clearly there is no such number. 0 is the answer. So thank you so much, Vijayini, for the good words. Yeah, half an hour thing. I also think that it is better to keep it half an hour because less time and maximum benefit from that half an hour. That is what we are trying. So all of you clear about this? So you have to know what are prime number. You have to know the test of divisibility. So both concept together was asked. And this question was asked in 2023 CSAT. And based on the last digit concept, you can do this question. 2's last digit we discussed. This question can be done in different ways. First of all, 57242, you only have to think about 2 because remaining numbers will not affect unit digit or last digit. 2 raised to 9 into 7 into 5 into 3 into 1. There are different ways of doing it. One way depends on the remainder theorem, but that explanation will take more time. But that is the faster solution. Explanation will be taking more time. That is why I will tell you the other solution. You have to multiply this first. 9 into 7, 5 into 3. 9 into 7, 5 into 3, 63 into 15. Yeah, in those of you have time, you can check out my lectures on Vedic maths and speed maths, where I have taught a multiplication technique to multiply faster, vertically and crosswise. In Sanskrit, it is called Urdhav Tiryakbhyam. Urdhav Tiryakbhyam means vertically first multiply 3 and 5, 15, carry over 1. 6 into 5, 30, 30 plus 3, 33, plus carry over 1, 34. Crisscross is the next step, crosswise. Then vertically, 6 into 1 you multiply, carry over 1, 7. So 745 will be the product. 740, sorry, not 7, 3 is the carryover. Na? So 945 will be the product. How to avoid steps of multiplication, that is what I just showed you. Again, if you don't want this normal multiplication, you find the number. So you got 945, 2 raised to 945. Now, about 2's power cycle we just discussed now. 2's power cycle is 2486. 2486 means 4 elements in the power cycle. If 4 elements are there in the power cycle, the procedure to follow is this. Cyclicity 2486. So the power, in the previous question the power is 945 now. 945 divided by 4, take the remainder. There also remainder theorem chapter I told you how to find the remainder faster. Na? 900 is a multiple of 4. So 900 plus 45 means 900 by 4 remainder is 0. 45 by 4 remainder is 1. So 1 is the remainder. 1 means first element in the power cycle. So 2 is the answer. 2 is the answer. Did you understand? Now I think you got a little more clarity on last digit of power. Otherwise, today I will share you a video I have taken recently on last digit of power. Those of you want to watch it can watch it. This was asked directly one time in UPSC exam, indirectly 1 or 2 times. This question, if you want, you can use this concept to do. If you want, you can do this question with remainder theorem idea also. It's also a hybrid question. Try it as a homework question. So and this was, again, we cannot conclude that this is a number system question. Number system idea, it's a reasoning problem based on number system. Reasoning is actually not having much math in it, but this is just observation. But you should know what are numbers, odd number, what is odd number is needed to do this question. That is why I am including this in the miscellaneous number system question. But this is actually a reasoning question. But without knowing odd number, you cannot do this question. So this question 2020 this was asked. Similar question was asked in 2019 also. So try this question super fast. And CSIR NET aspirants, do you remember? The same question was repeated in your paper in 2023 CSIR exam. That is why I am saying these exams can be are very supportive to each other to practice for each of the exams. Like CSIR exam and GATE exam PYQs will be helpful for UPSC, and UPSC and GATE PYQs will be useful for CSIR, and GATE and CSIR, GATE and CSIR and GATE, UPSC and GATE will be useful for CSIR also. So because many of the topics they ask very similar question, and sometimes from one exam they will take a question and ask it in the other exam. This happens quite often. I am following different exams for the last few years. That is why I am able to distinguish which all topics. You can see dicto same question. Some chapters difficulty level they will increase a bit or decrease a bit for other exams. So this question is super easy na. Many of you got the answer, I guess. How many odd numbers are followed by the odd number? Odd number means 1, 3, 5, 7, 9 na. Digits only we are discussing about. So odd digit. 5 followed by 1. So this pair we can consider. First pair. 5 is following that. 1 followed by 4. So that cannot be considered. 4 followed. 4 is not odd number. So not considered. 7, 3. So this can be considered. This can be considered. 3, 9. This can be considered. Third one. 8, 9 not possible. 8, 5 not possible. 5, 7 possible. Fourth one. 7, 2 not possible. 2, 6 not possible. 6, 3 not possible. 3, 1 possible. Fifth one. 1, 5 possible. Sixth one. 5, 8 not possible. 8, 6 not possible. 6, 3 not possible. 3, 8 not possible. 8, 5 not possible. 5, 2 not possible. 2, 2 not possible. 2, 4 not possible. 4, 3 not possible. 3, 4. 3, 4. 4, 6. These all are not possible. Okay, did I miss anything or did I count anything wrong? Let me check once more. 5, 1. 5, 1 is okay. 7, 3 is okay. 3, 9 is okay. 5, 7 is okay. 3, 1 is okay. 1, 5 is okay. So 6, option B is the answer. Okay, you got 5, 5, 5, 6 you can find now. Is it a counting mistake or some other confusion? Let me cross check once again. 5, 1, yes. 7, 3, yes. 3, 9, yes. 5, 7, yes. 3, 1, yes. 1, 5, yes. So 6 are there now. Clearly 6 are there now. Which one you missed? Can you mention which one you missed? Same question, 2020 question was there in 2019. Instead of odd number, just mention something else, but same observation pattern is enough. So these are observational ability problem, but as I told, what is odd number was needed to do this question. So it is added in this chapter. Yeah, some questions are like that. We cannot clearly mention which chapter question it is. So I think you got an idea about this number system unit in total. My lead IA students, the first 4 lectures will be shared to you as in the Sundays, so that you can watch that video, or if you want, you can directly visit this playlist and watch the video as per your convenience. Riju, it is not mentioned prime, na? It is mentioned odd number, na? Or did I read it wrong? Yeah, when I read it fast, I can make mistake. I'm not saying I cannot make mistake. Let me cross check, because I read it as odd number. Wasn't it odd number? Odd number followed by odd number is the question, na Sriju? No prime number mentioned. Question is, how many odd numbers are followed by the odd number? So prime number, there is no mention of prime numbers at all. Clear, na Sriju? That is why 9 should also be considered, because 9 is an odd number. Yeah, 9 is not a prime number, but 9 is an odd number, na? Okay, so that's it. I think today we can conclude here. More questions, miscellaneous question I will mention, and if you want practice question on arithmetic progression, geometric progression, I will add 1 or 2 questions on that also in the practice worksheet. So those of you haven't followed our Telegram channel, you can follow it. In the description you can find the link. Okay, I think the video is not video visible. The screen share visible or not? Visible, na? Okay, Sriju, no problem. Okay, so that's it. There is nothing else to discuss. We will conclude here. So number system, for any exam, number system is very important, and for UPSC exam, last 2023 UPSC exam, number system, about 23 questions, 23 or 24 questions, 20 to 24, that range. I forgot the number exactly now. So 20 to 24 questions were asked from this unit itself, this 8 topics itself. And all other exams, whether it is GATE exam, whether it is CSIR exam, SSC, PSC, bank exam, all exam, this is a common topic, number system unit. So you should learn it thoroughly, because for a non-math background student, this is a little tricky unit, because you have to revise all the important concepts you learned in school. That is what I have tried in this course also. I have tried to cover all those important elements that you missed or that you may have forgotten from school, and that we discussed. And in this flashcards also, all those concepts are already there. So those of you who want the flashcard as a single ebook file, you can check it out in our mobile application. Otherwise, in each class I am showing you flashcards anyway. So if that is enough, that is enough. But if you want as a material, you can check it out. So that's it. The flashcards are available in Kindle and Google Books also. Those of you want to check it out, that also you can. So that's it. No other doubts now. So let's conclude. Do let me know what you felt about this session, and do like this video if you felt this was useful, and do subscribe the channel and hit the bell icon. That will help you also, and that will help me also to grow a bigger community. For aptitude and speed math learning. Okay, so that's it. Thank you. Take care. Bye bye. Have a good night. See you all in the next class. Coming Monday, we will have the next class in the series. Other videos in this channel you can check out in the meantime. So thank you.